Hi, hello. Today we are going to discuss about the concept of singular and multiple points. So, before going to singular and multiple points, already we learned straight lines and the concept based on curves. So first we have to define singular point. So if we define singular point, first already we have to learn algebraic curves in the plane. So what do you mean by algebraic curves in the plane? A given plane may be defined as a set of points x, y satisfying an equation of the form f of x, y, which implies 0. Here the given function be a polynomial function. If it is a polynomial function, this given function defined by f from R2 to R, and if the same function f we have to expand it. Why we have to expand? Because we have to consider this is an algebraic curve, so that's why we have to expand. Therefore f is equal to a naught plus b naught x plus b1y plus c naught x square plus 2c1xy plus and so on. Now here, if the origin 0 comma 0 on the curve, then a naught is equal to 0 and b naught also 0, but b1 is not equal to 0. Origin is nothing but a naught and b naught. If a naught is equal to 0 and b naught is not equal, b1 is not equal to 0, then this given function is said to be implicit function theorem. It's not said to be an implicit function, but by the condition implicit function theorem, one smooth curve given function we have to consider that smooth curve be a, or smooth function be a h. By using h, this curve we have to define y is equal to h of x. Y is equal to h of x. That smooth curve or that smooth function is nearer to origin. Similarly, in some case, if b naught is not equal to 0, then there is a smooth function k, so that the curve has in the form x is equal to k of y. So already I said here a smooth function h, that h is very near to origin. In second case we have to consider b naught is a not equal to 0. Again we have to consider one smooth function k, so that smooth function is of the form x is equal to k of y, that k be a nearer to origin. In other case a smooth map from R to the given plane, which defines a curve in the neighborhood of the origin. B naught is equal to dou f by dou x, b1 is equal to dou f by dou y. We have to consider one function f of x comma y is equal to 0. That function, given function, we have to differentiate with respect to partially, or we have to differentiate partially with respect to x comma y. Therefore f of x comma y is equal to dou f by dou x, which implies dou f by dou y is equal double point. So double point we have to define by using a singular point only. So here also we have to consider a singular point of a given curve f of x comma y is equal to 0. That given function we have to differentiate partially. If we differentiate partially, that values which equal to 0, and at least 1 second of partial derivative of a given function also which is non-zero. So here one symbol, a delta, we are considering. So what they are given, a kind of singular point of a curve f of x comma y is equal to 0 at which the partial derivative are 0 and the least 1 second partial derivative of the given function f of xy is non-zero, then that is delta is equal to dou 2f by dou x square naught into dou 2f by dou y square naught minus dou 2f by dou x dou y whole square naught. So this is a case of a double integral. So here in the double integral we have to divide or defined one cusp and node and isolated point. So by this above conditions only we have to use here. So if delta greater than 0, the double point is said to be a isolated point. Thus the coordinate origin of the given curve y square minus x to the power 4 plus 4x square is equal to 0 is an isolated double point. Here one graph is there, we have to draw on graph. So by using that graph only we have to define that given equations also. By using this graph only we have to define. So similarly, if delta is less than 0, then again this given equation, this given function is said to be a node or nodal point. Okay, so double is similar. Here also one figure is there. So by using figure we have to write down that equations by using these equations. If delta is equal to 0, then the double point is either isolated or else characterized by a fact that at different branches of the curve we have a common tangent at the point. Thus at a cusp of a first kind, branches of the curve are situated on a different sides of the common tangent and the same side of the common normal. Again we have to draw on graph for a given point or cusp. Okay, multiple points. So multiple point is nothing but we have to consider a curve. It has a triple point from the origin. Trigonometrically we have to define x of t is equal to sin 2t plus cos t and y of t given function is equal to sin t plus cos 2t. In general, if all the terms of a degree less than k are 0 and at least one term of degree k is not 0 in a given function f, then the curve is said to have a multiple point of order k. Working rule. Step 1. So we have to consider given function. At given function we have to differentiate partially with respect to x, y, and second order partial differentiation we have to done. fxx, fyy and fxy. After differentiating, we have to solve the given equations by using singular points. Fx is equal to 0 and fy is equal to 0. If we substitute fx is equal to 0 and fy is equal to 0, then only we get a singular points. That points we have to say in a coordinate plane or coordinate points, that is a x comma y. Next, step 3. What we have to obtain a resulting value. Resulting value is nothing but a singular points. That singular points we have to substitute in a given function. If we substitute that coordinate points are that resulting points, if given value will be 0 or the product will be 0, that point be a double point. Then only we have to say that is a double point. Next, step 4. After finding double point, so one given formula is there, that is a fxy whole square minus fxx into fyy, which is a greater than 0. So by using this condition, we have to substitute given function, we have to substitute here. After substituting, the resulting value is greater than 0, then given function is or the nature of function be, nature of double point be null. Otherwise, if given function fxx fxy whole square minus fxx into fyy, which is equal to 0, or the resulting value is always equal to 0, such a point is said to be cusp. CUSP. Some case, if the resulting value is less than 0, if the resulting value is less than 0, such a point is said to be isolated point or conjugate point. Such a point is said to be isolated point or conjugate point. One example. Find the position and nature of a double point on the cone x square into x minus y plus y square is equal to 0. Let us consider given function f of x comma y is equal to x square into x minus y plus y square, which equals 0, or we don't consider 0. So we have to remove the brackets, or we have to solve, we have to substitute here. If we multiply, or if we have to remove the brackets, then given function x cube minus x square y plus y square, which is equal to 0. So here next condition, we need to find fx fy. So then partial differentiation with respect to x is nothing but 3x square minus 2xy. Partial differentiation with respect to y is nothing but minus x square plus 2y. According to working rule or by the condition of singular points, fx is equal to 0 and fy is equal to 0. Then substitute here 3x square minus 2xy is equal to 0. Here minus x square plus 2y is equal to 0. Then 2y is equal to x square. The 2y value we have to substitute in the equation 1. Then 3x square minus x cube is equal to 0. So we have to take x square be a common term. It may be 3 minus x is equal to 0. X square is equal to 0 and x is equal to 3. Therefore x is equal to 0 and x is equal to 3. Now here when x is equal to 0, we have to substitute, we need to find y value also. When x is equal to 0, then y also 0. When x is equal to 3, then y is equal to 9 by 2 from equation 1. Therefore the coordinate points are 0, 0 and 3, 9 by 2. These 2 points are singular point. Next, if we substitute above these 2 coordinate find given a function, if that given function always the product will be 0, that point be double points. If it is not equal to 0, that is not a double point. So here we have to substitute 0, 0, that is the origin. If you substitute origin, the product always 0. So let us consider 0, 0 be a double point. Okay, so clearly 0, 0 is a double point, since at 0, 0 f of x, y be 0. Next, at 3, 9 by 2, this given function is f of 3, 9 by 2. The given equation f of x, y, x cube minus x square y plus y square is equal to 0. F of 3, 9 by 2 is not equal to 0. So 3, 9 by 2 is not a double point. Now last step, fourth step. So therefore there is one formula, fxy whole square minus fxs into fyy is a partial second order partial derivative. So we have to differentiate. fxy is nothing but the product will be minus 2x. So substitute here minus 2x whole square. So differentiation, second order differentiation of fx with respect to x is nothing but 6x minus 2y into fyy is nothing but 2. Substitute here. After substituting, the resulting value 4x square minus 12x plus 4y. So we have to substitute here double points. What are the double points? 0, 0. So f of 0, 0 is equal to 4 into 0 minus 12 into 0 plus 4 into 0. The product also 0. F of 0, 0 is equal to 0. So already in a working group I told, if the last resulting value is 0, then that double point is said to be cusp. If it is a greater than 0, then the double point is said to be node. If it is a less than 0, it is an isolated point. But here it is 0, product is 0. So therefore the nature of a double point is cusp. So this is the procedure to solving the problem. Thank you.